Okay, so in this video, we're going to learn about conditional probability. We'll talk about what that means in a minute, but first let's review some of the probability sample space notation that you've seen already. So what I'm going to ask you to do is pause the video and write down these four and see if you can remember what they mean. All right, so hopefully you got this, that the first one's the probability of A, the second one's the probability of A and B, or A intersect B. So this is a single probability, but two conditions are being met. The next one is probability of A or B, or A union B. Again, this is a single event probability with two conditions being met. Probability of A complement B. Sorry, not complement B, probability of the A complement. So that just means the probability of not A, right, of A not happening. So conditional probability is again another single event probability. And it's written like this, the probability of A given B. All right, so that's just a straight up and down line. It kind of looks like that absolute value line. And I would write down that this is the probability of A given, and I should have made that a capital, A given B. And what that means is that given, this given B, means that given B is already true. Another way to think about that is maybe to replace this word given, because you're going to read given, but you can replace it with the word if. The probability of A if B has already happened. So we're going to look at how we calculate that and kind of how that plays out. All right, so this is another one of those two-way tables. I think we've talked about these already. So this is talking about if you have a headache or not. That's one of the conditions. The other condition is if you took medicine or did not take medicine. So we've said, this says here that A is the event that they did not get a headache. So A is going to be, and I'll circle instead of highlight, A is this whole section right here. This is not getting a headache. That's event A. And event B is, sorry, I'm jumping back and forth. Event B is that they took medicine. So event B would be this right here, that they took medicine. Okay, so you could do a few things, and let me just kind of review some stuff with you. If we did probability of A and B, that they had a headache and they took medicine, well, there's 54 people in that category, right? That's this right here. So the probability of that would be 54 out of 100. If I did the probability of A or B, that would be all the ones that took medicine, so that total of that is 65, plus all the ones that didn't have a headache, that's 76, and then I subtract the overlap, which is 54, again, all out of 100. All right, now, we're going to talk not about that. I just wanted to show you that to remind you of what that looks like. So this time, I want to show you how do we calculate given probabilities. So let's do one this way, probability of A given B. So this means, sorry, you can hear my kid. This means that B is already true, right? This is the one, the B we said is the part that's already true. So that means when we're looking at this table, we're really only looking at the part of the table where they took the medicine. So I don't care about this part where they didn't take medicine because I already know they took it. So now when I go to calculate that probability, it's going to tell me that the probability of A, they don't have a headache, knowing that they already took the medicine, is 54, but this time it's out of 65 because I only care about the number of people that took the medicine. All right, so let me show you another one. Let's do the probability of B given A, because you can go the other way. So this time we know that A is the true statement. So we already know that they did not have a headache. So if we know they didn't have a headache, that means I don't care about this whole part of the table where they did have a headache. That's irrelevant to me. So what I care about is if they did have a headache. So this time, the probability of B, so notice I'm really focusing just in this yellow circle now. The probability of B, which is that they took medicine, that's this 54, whoop, switch pins. All right, 54. And this time it's that they did that and they didn't have a headache. That's out of 76. Okay, so the one thing that I want you to notice, well, that's a lie. There's two things. The two things I want you to notice are, first of all, these numerators happen to be the same. And those numerators match, hopefully you see they match the intersection. All right, we're going to kind of summarize this rule here in a minute. The big thing that I want you to remember with given, though, is that in given, the denominators change. Because we're not talking about the entire study or entire set of things. We already know one of the conditions to be true, so we can cut down on the number of possibilities. So the big thing I want you to write for given is that denominators change. Okay, so here's a question already written out in words, and so I'm going to help you kind of understand how to write that in terms of writing the probability. So this one says, find the probability that a red card, randomly drawn from the deck, is a jack. So that a red card is drawn, this is the part that they're telling me is already true. They're already telling you that you're going to draw a red card. The question is, what's the probability that it's a jack? So this is saying, what's the probability that you get a jack given that you know that the card is red? Okay, so like we said before, we want to find out if it's a jack, but first we have to figure out, or like kind of whittle down to where we're just looking at the red cards. So I'm going to cross out all these cards that are black and just look at the red cards. Remember, that means we're talking about the diamonds and the hearts. So if we know that we're talking about the red cards, the jacks here, in this case, there's only 2 jacks that meet that qualification. So the probability here is going to be 2. And out of the red cards, now if we're just talking about red cards, there's only 26 red cards. So the probability here is going to be 2 out of 26. Now, this question isn't asking you this, but I just want to show you that the probabilities don't go 2 ways when you're doing conditional. So you kind of saw that on the last one, but I'm just going to show you again. If we do the probability of red, given that we know we've, I'm writing what I'm saying, given that we know it's a jack, this time we're just looking at the 4 jacks. So there's only 4 jacks, excuse me, and out of those 4 jacks, 2 of them are red. Notice those probabilities don't match at all, but again, the part that does match is the numerator. That's the intersection between the 2 qualifications, and then the denominator is changing based on whatever was given. So this rule, in general, looks like this. Conditional probability, A given B, is the intersection, all right, that's what goes on top, the numerator, where both events are true, out of just the probability of B. And sometimes you can remember that when you're looking at the statement itself and think about this line, this given line, as a denominator, right, as the saying divided by B. That's not really what it's saying, but it's just kind of a visual reminder. I don't generally use this rule. I honestly, I don't really use a whole lot of rules in probability because I just like to make common sense of it, but feel free to write that rule down to use it as you see fit if you do feel like you do well with rules and kind of structure for that.